So here's an example of a problem that's not exceedingly easy to do using triangles, but it's also not that easy to do using the traditional methods either. So in a problem like this, you're told that you've flown 52 miles and you've been blown 6 miles off course. You've got 118 miles to fly to get to your destination. So you don't know what your winds aloft are, but you know that they've blown you 6 miles off course, and you have to figure out what wind correction angle you need to use to get back to the destination that you were originally trying to get to. So let's draw this out. You're flying along, you've flown 52 miles. During that 52 miles, the unknown winds aloft have blown you 6 miles to the left of course, and you've got 118 miles still to go. So the first thing that I like to do when solving these problems is figure out how far I'd get blown off course if I didn't make any correction at all. And that's the distance that I need to make sure I have compensated for by the time I get there. So the idea here is that if I was flying along from the starting point and I'd use the correct wind correction angle from the get-go, then I would have needed to have made up for this distance that the winds were going to blow me. Alright, so that distance can easily be found by just linearly extrapolating the distance that you've already been blown off course. So you've flown 52 miles, you've been blown 6 miles off course. If you fly another 118 miles, you can just set up a proportion and find that you'll be blown another 13.6 miles off course, for a total distance of 19.6 miles off course. So that 19.6 is what you need to make sure that you compensate for. Okay, so draw a line that shows the destination that you're that shows the direction that you need to point your nose. And that is going to be the 6 miles that you've already lost, plus the 13.6 miles that you need to make up, because that's what the wind would continue to blow you if you kept flying the course you were on. Okay, so this is the line that shows where you need to point your nose in order to get to the nav aid. The only question is, what angle is that? So to find the angle, just overlay a right triangle on top of your situation. So you know that the top of this right triangle has a length of 118 miles, because that's how far you have to fly. And you also know the length of the opposite side. It's the 6 miles that you need to make up, plus the 13.6 miles that you still need to worry about, because that's what the wind will blow you if you keep flying the way you're flying. So you've got the adjacent side and the opposite side with respect to your unknown wind correction angle. Anytime you have an opposite side and an adjacent side and an angle, and you don't care at all about the hypotenuse, that's a good setup for a tangent problem. And in this case, since you're solving for the angle and not the ratio, it's an arctangent problem. So compute the arctangent of 13.6 plus 6 over 118. That's the opposite side over the adjacent side. And you get a 9.43 degree wind correction angle. If you go back to your choices, you see that you have an option of 10 degrees. And 10 degrees is reasonably close. It also happens to be correct. Now the reason that the 10 degrees is not exact is because the FAA is using an approximation formula where instead of doing sines and cosines, they just use they use 60 nautical miles per 1 degree of deflection for every 1 nautical mile off course you are. That's the foundation of their approximation formula. And the problem is that's not exactly correct, because the actual value is 57.2 miles away from a nav aid, gives you a 1 degree deflection for every 1 nautical mile off course you are. And that variation of about 5% accounts for the difference between our 9.4 something number and the 10 number that was given as the correct answer. So in general, for these type of problems, you can use this formula if it so suits you in order to unambiguously solve any problem. But that formula is kind of messy, looks difficult to remember, and it's probably easier and better for your overall situational awareness to just draw out the triangle, because you're a lot less likely to make a mistake.